In the previous video, we talked about rule-based intonation teaching. Now, let's explore the acoustic-based approach to teaching intonation. The acoustic information of sounds can be visualized using the software Praat. In Praat, the upper window of the view window presents us with a visual representation of sound waves and amplitude. It shows how the air moves when the sound is produced, and how loud the sound is. In the lower window, you can see the energy bars in the background. It consists of a variety of acoustic information represented by different markers. The red dots show the position of the tongue during sound production. When the red dots form a steady line, it indicates the portion where the vowel is. On the other hand, the messy red dots signifies the positions of the consonants. The blue lines represent pitch, meaning how high or low the sound is. The green lines represent intensity, indicating how loud the sound is, like amplitude. The duration of the sound is displayed at the bottom. In this video series, we only focus on how to visualize intonation. Intonation can be influenced by various factors, including pitch, energy, duration, tempo, and sound quality. Among these factors, pitch plays the most crucial role. Thus, we just pay attention to the pitch, as shown in this example. By observing the intonation contour, we can know the variation in pitch levels during the articulation of an utterance. Now, let me visualize the pitch contour of the monosyllabic word no as the nucleus, assuming a native speaker is using 3 different tones to answer the same yes-no question with a no. First, open the software Praat, then click the Open button and choose Read from File. Choose the audio file you want to analyze, and click Open. The audio file will appear in the Object window. Select the audio file you just import, and click View and Edit to open it. To enable visualization of the acoustic cues, click the Analyses menu and choose Show Analyses, tick Show Spectrogram and Show Pitch. The blue line indicates the pitch. To listen to the whole recording, click anywhere in the marginal area surrounding the spectrogram. Then we can either click on Visual Part at the bottom of the window, or press Tab on the keyboard. Additionally, we can drag the cursor to make a selection based on the spectrogram to play a specific part. By analyzing the trend of the pitch contour, we can identify that the 3 tones used by the native speaker are fall, rise, and fall rise respectively.
No. No. No.
Now, it's your turn to practice intonation visualization using Praat. Please open the software Praat on your computer and visualize the audio file, Christmas Presents _3 tones. The link for downloading Praat and the sound files are provided in the video introduction. Please follow the procedure on this slide to visualize the noun phrase Christmas presents, and determine which tones are used for the nuclear syllable and the syllables following it. If you can obtain the pitch contour similar to mine, it means you are correct.
Christmas presents. Christmas presents. Christmas presents.
Now, let's observe the pitch contours of the word no and the phrase Christmas presents with 3 tones together.
No. 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 Christmas presents. Christmas presents. Christmas presents.
It is clear that the contours of each tone show a similar trend regardless of the number of syllables in the nucleus.
No. Christmas presents. No. Christmas presents. No. Christmas presents.
However, for Chinese learners, it is commonly found that they tend to place equal emphasis on each word, resulting in the words within a phrase being separate and sounding similar to the dictionary audio clip.
Christmas presents.
In natural speech, actually, the rest of the phrase following the nuclear tone keeps the pitch until the end, instead of initiating a new pitch start.
Christmas presents.
Let's move on the nucleus that is embedded in a sentence. Before listening to the recording, let's analyze the intonation pattern of this sentence together by following the 4 steps. First, determine how many intonation phrases are included. This is a simple sentence and it's short, so it has only one IP. Next, identify the content or important words. There are 3 content words in this sentence, including got, science, and background. They are all accented. Both got and science are monosyllabic words, so we don't need to consider the primary stress of them. While for the disyllabic word background, the stressed syllable is back. As for the rest of the words, they are deaccented. Then, let's choose the nucleus among the 3 content words. This sentence is a normal yes-no question and has unmarked tonicity. So the first syllable of the last content word background is the nucleus, thus carrying the nuclear tone. And finally, decide the pitch pattern. Considering the discourse function of this sentence, it's a yes-no question, so we can use a default rise. Then, any attitude you want to express. Perhaps we can ask it in a more polite way. So either a rise or a 4 rise can be used here. As for the accented words got and science, they can be uttered high in pitch. Given that the word any follows the accented word got, it might be uttered in high-level pitch as well. For have you, they can be low in pitch. Now, let's observe the intonation contour, still without listening to the recording. You may notice that the pitch starts low at the beginning, and then goes slightly higher, and keeps a similar level to the central of the sentence. After that the contour moves downwards, and then upwards again, which seems like a 4 rise. After the preliminary analysis, let's listen to the recording.
Have you got any science background?
We can say our analysis is relatively consistent with the intonation pattern used by the native speaker. This time let's listen again to the recording and observe the pitch contour at the same time.
Have you got any science background? Background.
The contour is quite clear, particularly the 4 rise part, very beautiful. Right? Now, we know how to visualize pitch contours of monosyllabic words, phrases, and sentences. Actually, we can also record our pronunciation using Praat directly. This can also be used in your classroom for advanced students. If they have laptops or are in a computer lab, you can ask them to record their own reading and perform self-analysis using Praat. Now, please follow the instructions here to record your own reading of Have You Got Any Science Background, using Praat for intonation visualization. First, click on New in the menu bar of the object window, and select Record Monosound. Next, click on the Record button on the new sound recorder window to start recording your reading. After reading the sentence, click on the Stop button to end the recording. Click on the Name field to name the recording. Then click on the Save to List and Close button. Lastly, return to the object window, select the recording and click on View and Edit to start visualization. If the recording is too noisy, you can go back to the object window. Select the recording, click Filter and Reduce Noise, and click OK to proceed. You can then start visualization using the denoised recording. It's also worth mentioning that when analyzing pitch contours, we need to consider the pitch range of the speaker. For a male voice, it is recommended to set the floor at 75 Hz and the ceiling at 300 Hz. For a female voice, a range of 100 to 600 Hz is typically suitable. To modify the pitch range, you can access the pitch settings within the pitch menu. Hopefully, by now you have gained a thorough understanding of using Praat to visualize intonation. When dealing with sentences, we can destructure them by focusing on the nucleus, and post-nucleus syllables, pre-nucleus part, and the sentence as a whole. Let's take a look at the pitch visualization of a new sentence. In this case, the pitch visualization is extracted from a web-based platform WASP, which can be seen as a simplified version of Praat. This tool will be introduced in the last session. Even without listening to the recording, you can identify the nucleus by observing the intonation contour. You may notice that there is a step up in pitch. And after that there is a downward pitch movement from difference to the end of the sentence, which seems like a fall. Indeed, the first syllable of difference is the nucleus. Now let's listen to the recording segment by segment.
Difference to my life. Big difference to my life. Made a big difference to my life. Really made a big difference to my life. It's really made a big difference to my life.
Using this acoustic-based method is advantageous in 3 aspects. First, visual representations help learners understand pitch patterns more easily and connect what they hear with what they see. Second, objective analysis and perceptual visualizations help teachers give precise feedback and assessments to learners. Learners can also track their progress by comparing their own pronunciation to visual representations of correct pitch patterns. Lastly, the acoustic-based approach allows learners to reproduce and imitate the visualized acoustic patterns associated with intonation. To be honest, this method may also have disadvantages because it has requirements for the teacher and the students. The acoustic-based approach requires a certain level of understanding of phonetics and the ability to interpret and analyze acoustic cues. Understanding and interpreting the visual representations of sounds may be technically complex for some learners unfamiliar with IT. There are many possible teaching activities to be developed based on the acoustic-based teaching method. First, the visualized information can be used as a visual aid to establish norms you hope the students learn from. You can conduct acoustic analysis on the target pitch patterns used by native speakers or teachers and use the acoustic information as visual aids in the classroom. Students can easily understand the pitch pattern with the help of the visual aids. Second, the visualized information can be used as a feedback tool to bridge students' production and perception of intonation. Many students may have difficulties in perceiving their own inappropriate intonation since sounds are invisible and intangible. Teachers may collect their reading of words, phrases, or sentences and use acoustic visualization with annotations with the errors as feedback. Therefore, the students can precisely know the errors and make adjustments accordingly. Third, advanced students can conduct self-analysis in a computer lab guided by teachers. Teachers can prepare pictures of acoustic visualization of the target pitch patterns used by native speakers or teachers themselves as the norms. The students can read the target pitch patterns in part, compare their acoustic visualization to the norms, and adjust their own reading to be more similar to the norm.